Elon Musk might just blow the world's mind if this Naxtra battery tech makes it into Tesla EVs by the end of the year. In fact, this battery could change Tesla electric vehicles forever. We're not saying it's better than the 4680 cells, but it's definitely way cheaper than the best batteries Tesla currently has. Why? Because it's made from materials that are abundant around the world, unlike the scarcity of lithium. Yeah, we're talking about sodium, the element you can find literally everywhere. In the ocean, underground, or even in your kitchen salt shaker. And it doesn't stop there. This is the first sodium battery in the real world to hit performance levels that rival top-tier batteries. We mean 310 miles on just a 5-minute charge. Not to mention it has a much lower risk of fire compared to lithium-ion batteries. CATL says this battery could reshape the entire industry and replace half of the LFP battery market. And LFP is already one of the cheapest types of batteries out there. So if Naxtra can beat LFP, it could be the key to truly affordable EVs under $25,000, something Tesla is still struggling to pull off. So, what exactly makes this battery so special? When will it be available in EVs? And why is it likely to show up in Tesla EVs very soon? Let's dive in and find out. The truth is, not long ago, EV skeptics and critics used to say they wouldn't even consider buying an electric car unless it had at least a 300-mile range. Well, that barrier has already been shattered. EVs today can easily hit 400 to 500 miles of range. But now, the conversation has shifted. The latest complaint? Charging time. Now those same EV naysayers are saying they won't switch over until an electric car can charge as fast as it takes to fill up a gas tank. Let's be real. People will always find some reason to dismiss progress. But if an EV can add 300 miles of range in just 5 minutes, we truly believe there won't be a single excuse left to look down on electric vehicles. And yes, that kind of battery is now real. CATL, Tesla's largest battery partner, has developed what could be the most well-rounded battery yet. It flips the whole script that lithium is irreplaceable by using sodium, an element that's 1,400 times more abundant than lithium. Now let's address the elephant in the room. When something launches in China, especially tech, a lot of people automatically assume it's fake, exaggerated, or just a knockoff. But this time we're talking about CATL, the #1 battery manufacturer in the world, with over 18.32 million electric vehicles powered by CATL batteries across 66+ countries. And here's the thing, CATL has never lied about their battery performance. This is no hype, it's happening, and the game is about to change. In fact, CATL became the first automotive battery manufacturer to launch sodium-ion batteries in 2021. But due to limited performance parameters, the commercialization of the first generation of sodium batteries has not been widely expanded. But now, CATL's Naxtra battery has broken the performance boundary of the material itself, achieving mass production of sodium-ion batteries for the first time. Specifically, CATL's Naxtra EV battery achieves an energy density of 175 watt-hours per kilogram, the highest among sodium-ion batteries worldwide and comparable to LFP batteries. This enables the Naxtra battery to help EVs achieve a range of 500 kilometers and can achieve more than 10,000 cycles, significantly reducing maintenance costs. You may not know, but achieving an energy density of 175 watt-hours per kilogram for a sodium battery is extremely difficult. Why? In fact, the energy density of sodium batteries is usually quite low, only around 130 to 150 watt-hours per kilogram. The reason is that sodium ions are larger in size than lithium ions. This means that more space is needed to accommodate sodium ions when the battery is operating. As a result, the cells in sodium-ion batteries need to be larger or have more space to accommodate the required amount of ions, resulting in a lower energy density. On the other hand, sodium is heavier than lithium. This means that sodium-ion batteries will be heavier in mass compared to lithium-ion batteries of the same capacity. This makes the energy density by weight watt-hours per kilogram of sodium-ion batteries lower than lithium-ion. That is why sodium batteries have consumed years of research by millions of researchers around the world just to find a way to make it have a higher energy density, and CATL is proof that they have found a practical solution. Of course, we have to admit that the energy density of 175 watt-hours per kilogram is not an impressive number. Compared to the 4680 battery with a density of 272 watt-hours per kilogram, the Naxtra battery is still quite far away. CATL's goal is that sodium batteries can soon reach 200 watt-hours per kilogram, but at the moment, it seems that this will not happen anytime soon. Despite having an average energy density on the contrary, the Naxtra battery's charging time can blow any battery away, with just 5 minutes of charging giving you 310 miles of range. For any battery technology, the key factor in determining whether charging is fast or slow always lies in the movement of ions between the electrodes during charging and discharging. In Naxtra batteries, sodium ions move between the anode and cathode through the electrolyte. One of the reasons why these batteries have high charging and discharging speeds is the favorable ionic conductivity of sodium ions in the electrolyte. Sodium ions carry a single positive charge, similar to lithium, but their larger ionic radius allows them to move relatively easily through certain electrolytes, especially those optimized for sodium-ion batteries. In liquid electrolytes, sodium can exhibit rapid diffusion, facilitating faster ion transport during both charging and discharging processes. This speed means it's capable of fully charging a Tesla Model Y in just 5 minutes. Oh my God, that's clearly close to the experience of refueling a gasoline car. Customers also experience reduced range anxiety and increased confidence when using electric vehicles. In addition to the ultra-fast charging potential for EVs, similar to gas refueling, the ultra-fast charging advantage of Naxtra batteries also benefits power tools or heavy-duty industrial equipment. The high discharge rate ensures that the Naxtra battery can deliver the necessary power within a short time frame, supporting demanding workloads. This makes sodium-ion batteries an attractive option for high-power applications that require instant energy delivery. As we mentioned earlier, Naxtra batteries not only have a cost advantage, but they can also be considered one of the safest types of batteries for electric vehicles. This is evidenced by CATL sharing results from a series of rigorous stress tests, including drilling into a cell and even cutting it in half, without any thermal events occurring. This is largely thanks to the sodium-based chemistry inside the battery. According to CATL, the Naxtra battery can operate across a wide temperature range from -40 degrees Celsius to over 70 degrees Celsius, redefining the extreme temperature limits of batteries. The Naxtra battery retains 90% of its usable capacity at -40 degrees Celsius. Even at an extremely low state of charge, it shows no significant power degradation at -40 degrees Celsius. Compared to lithium batteries, sodium-ion batteries inherently have better resistance to overheating, reducing the risk of fire or explosion under thermal stress. Studies show that sodium-ion batteries are less flammable due to their more stable chemical structure and are less likely to explode in the event of a short circuit, offering a higher level of safety in technical failure scenarios. Additionally, sodium is a non-toxic material, minimizing health risks in the event of battery breakage or damage. You no longer have to worry about terrifying EV fires with thick plumes of smoke from lithium batteries. One standout advantage of sodium-ion batteries that we particularly value is their ability to maintain stable performance at low temperatures. Many have demonstrated that they can still charge from 5% to 80% in just 15 minutes, even at -10 degrees Celsius. This makes sodium-ion batteries an ideal choice for regions with harsh winters or cold environments, where EV performance degradation during winter is one of the main reasons many consumers are still hesitant to adopt electric vehicles. Therefore, Naxtra batteries may shift public perception and spark a revolution by offering minimal capacity degradation at low temperatures and functioning efficiently in extreme cold down to -40 degrees Celsius. The so-called winter range anxiety for EVs might soon fade away. Although CATL has not disclosed the exact cost of each battery cell produced, if sodium-ion batteries are manufactured at scale, they could be 20% to 30% cheaper than LFP batteries, mainly due to the abundant supply of sodium and its low extraction and refinement costs. Sodium-ion batteries can also use aluminum for the anode current collector instead of copper, which is used in lithium-ion batteries, further reducing costs and supply chain risks. Replacing all lithium in lithium-ion batteries with sodium could lead to up to a 30% reduction in cost. What does that mean? That 30% is a huge advantage. In many cases, just a few percentage points in price difference can determine the survival of an industry. As we mentioned earlier, sodium is the primary component of Naxtra batteries, easily found in many places and much cheaper than lithium. Sodium is the sixth most abundant element in the Earth's crust, while lithium is relatively rare and mainly extracted from mineral deposits and brine, making its mining and transportation more expensive. Lithium mines are concentrated in specific regions such as Chile and Australia, which causes price volatility, but that's not all. Lithium-ion batteries often require rare materials, like cobalt, nickel, and lithium, which drive up production costs. In contrast, sodium-ion batteries primarily use sodium, a common and inexpensive metal. Some sodium-ion battery manufacturers also use cathode materials, like manganese or iron instead of cobalt, further reducing costs. According to a 2022 report by ID TechX, the production cost of sodium-ion batteries could drop to around $100 per kilowatt-hour, while current lithium-ion battery costs are around $140 to $150 per kilowatt-hour. This shows that sodium-ion technology could be 30 to 40% cheaper than lithium-ion. The production of sodium-ion batteries is expected to begin in June, starting with small starter batteries for heavy-duty trucks under the Naxtra brand. These new batteries are expected to offer a significant advantage for vehicle startups in cold weather. Mass production of larger batteries for electric vehicles and hybrids is expected to begin in December this year. So far, the 4680 battery remains Tesla's best battery. Unfortunately, it's currently only available in the expensive Cybertruck rather than across other models, prompting many to ask, when will the 4680 battery truly become abundant and available in more affordable EVs? Moreover, it's been a long time since Tesla introduced a new, more efficient battery, which reinforces the growing belief that Tesla is falling a decade behind Chinese automakers. From what we know, Tesla still sources 4680 batteries from multiple suppliers, including Panasonic and LG Energy Solution. The company has also been working to scale up its internal battery production over the past few years, reaching a milestone of 100,046,080 cells produced as of September last year. While Tesla is no longer struggling to refine the 4680 battery, Elon Musk confirmed record output levels at Giga Nevada. Many critics argue that the 4680 uses outdated chemistry and powers vehicles that can't maintain a 2C charging rate. Meanwhile, Chinese OEMs already have cars on the road that can sustain 4C charging for most of the cycle and are moving quickly to commercialize semi-solid-state and sodium-ion batteries on a large scale in the very near future. The Tesla Model 2, an electric vehicle Elon Musk once mentioned with a target price of $25,000, remains one of Tesla's biggest mysteries. While it is expected to be an affordable EV for the mass market, one of the key factors in achieving that price point is battery cost. Although Tesla has adopted LFP batteries for more budget-friendly versions of the Model 3 and Model Y, there's still a significant gap to reach the $25,000 price goal that Musk proposed for the Model 2. In other words, LFP batteries are not yet cheap enough to make the Model 2 viable at that price point. Tesla adopting sodium-ion battery technology, such as the Naxtra battery, would be a logical and strategic move to reduce electric vehicle production costs, especially considering Tesla's long-term partnership with CATL. This technology could help Tesla achieve its goal of producing the Model 2 at a $25,000 price point, while reducing reliance on more expensive battery types like lithium-ion. However, tariffs and other trade-related factors will need to be taken into account to ensure the feasibility of applying sodium-ion batteries in the U.S. market. So can Naxtra sodium batteries replace lithium batteries? In our opinion, the answer is no. Sodium batteries will not replace lithium batteries in the short term. Within the industry, it is widely believed that sodium-ion and lithium-ion batteries are complementary, not replacements for each other. Due to the lower energy density of sodium-ion batteries, they are more suitable for use in medium to low-speed electric vehicles and in large-scale energy storage systems. As industry investment increases, the technology matures, and the supply chain improves, cost-effective sodium-ion batteries are expected to become an important supplement to lithium-ion batteries, particularly in the field of stationary energy storage. They have a strong potential for development. Battery demand generally revolves around higher capacity, faster charging speeds, improved safety, and lower cost. From this perspective, aside from not yet being able to meet high-capacity needs, sodium-ion batteries have advantages in all other aspects. At this stage, Sodium-ion battery products will primarily be used in applications requiring less than 150 watt-hours per kilogram, which could help alleviate the limited development of energy storage systems due to lithium resource shortages. There are no obvious bottlenecks for large-scale mass production of sodium-ion batteries, and they will rapidly gain market share with their unique characteristics in specific markets. Sodium-ion batteries are positioned as the most cost-effective and highly safe energy storage batteries. Once mass production is achieved, their performance is expected to reach that of lithium-ion batteries, but at the price of lead-acid batteries. The development of sodium-ion batteries is a process of self-innovation. Eventually, sodium-ion batteries will directly compete with lithium batteries for market share. Although CATL has outlined a clear timeline, the industrialization of sodium-ion batteries still needs to overcome challenges related to technical performance, supply chain development, large-scale manufacturing, and cost reduction. The inherent limitation of low energy density in sodium-ion batteries is widely acknowledged, and efforts to optimize this have never stopped. Increasing the energy density from 160 watt-hours per kilogram to 200 watt-hours per kilogram has become the key R&D goal for CATL's second-generation sodium-ion batteries. Naturally, improving energy density presents a time and effort-intensive challenge. Beyond energy density, current sodium-ion batteries can reach a cycle life of up to 5,000 cycles, though this is still significantly lower than that of commercial lithium iron phosphate batteries, which can last 8,000 to 10,000 cycles. To become the backbone of energy storage applications, sodium-ion batteries still need to go through further technical validation and improvement. In addition to Naxtra, CATL has also introduced the second generation of its Shenzhen battery, which is expected to be installed in 67 vehicles this year from Chinese brands like Zeekr, NIO, and Avatar. This fast-charging battery can support a range of 800 kilometers and deliver 520 kilometers of range with just 5 minutes of charging, outperforming rival BYD from China. Its charging speed is truly impressive. CATL shared examples of vehicles charging at around 1,000 kilowatts, maintaining over 500 kilowatts even when the battery is more than 50% charged. CATL is also betting on the growth of battery swap systems, such as with its partner NIO, to help roll out its new battery technologies more widely. In summary, Naxtra sodium-ion batteries are emerging as a promising alternative to lithium-ion batteries in electric vehicles and energy storage applications. Over 18.32 million vehicles equipped with CATL batteries are currently in operation across more than 66 countries, demonstrating the reliability and effectiveness of the technology. Thanks to their high safety and the abundant availability of sodium-ion batteries reduce dependence on lithium resources, which is a key factor in solidifying the foundation of next-generation energy technologies. This shift not only brings sustainability benefits, but also drives the transition from resource dependence to energy independence, a major leap toward achieving clean and efficient energy goals. Technical issues like slower charging compared to refueling have already seen significant improvements, making EV charging more convenient. However, infrastructure development and technology costs still remain critical factors in making sodium-ion technology widely accessible to consumers. Forecasts suggest sodium-ion batteries could become mainstream within 2 to 3 years, even though lithium-ion remains the dominant choice for EVs at present. However, one concerning factor is that tariffs on advanced batteries imported from China could cause the U.S. to fall behind in the global EV race. This not only gives Chinese EVs a competitive edge, but also makes large-scale energy storage deployment in the U.S. more expensive and risk-prone, posing challenges for domestic clean energy manufacturers and infrastructure rollout. Millions, even tens of millions of people around the world are eagerly waiting for Tesla to release the Optimus robot to the public as soon as possible, as most believe things like, "It'll take care of all the boring housework for me. I'll use it in my store instead of hiring staff," or "I'll have it give me a massage every day," and so on. However, in the face of this widespread anticipation and the dream of owning Optimus, Elon Musk dropped a bombshell. Optimus will only be sold in the US. More precisely, Tesla will focus on the domestic market. Oh my God, we believe quite a few people were left stunned by this announcement, especially since Musk had previously stated that anyone in the world would be able to own Optimus, that Tesla would sell them globally, and that all 8 billion people could potentially have one. Tesla even showcased Optimus in China and Japan, which led most to believe it would be available in every market. Yeah, and in the end, that didn't happen. There's definitely a reason behind this, and Optimus is facing a major obstacle it must overcome. If Tesla succeeds, its commercial strategy for Optimus may change. So why is the Optimus robot only being sold in the US? All of this was revealed during Tesla's Q1 2025 earnings call. In addition to shocking updates, like Elon Musk announcing that he would no longer be heavily involved with Doge, starting in May to refocus on Tesla amid the company's serious downturn. Tesla's Q1 profit was only $409 million, a drop of over 70% compared to $1.4 billion in the same period of 2024. Throughout the meeting, aside from questions about the development process of the humanoid robot Optimus, an investor asked about Optimus's supply chain. This was an important question because Elon Musk had declared last month that the Tesla bot production line would be ramped up rapidly, with 5,000 units being the most optimistic target for this year. Elon Musk has repeatedly emphasized that if we own Optimus, we won't have to spend hours doing boring chores like cleaning, mowing the lawn, doing laundry, or lifting heavy objects. Instead, there would be a humanoid robot ready to do all of that, allowing you to make better use of your precious time, relaxing, caring for your family, or even working on personal growth. Especially on weekends, who wants to waste their valuable days off doing housework, right? Everyone wants to enjoy those moments, not be consumed by busyness. And that's exactly why Elon Musk is developing the Tesla bot. If it succeeds and goes into mass production next year, it could mark a major turning point, not just in technology, but in how we live and work. However, it seems even Elon Musk didn't anticipate a major obstacle that has hit Optimus. A crucial component that significantly impacts Optimus's usefulness is dependent on China. Specifically, China's tightening of rare earth exports is directly affecting the Tesla bot Optimus, making it difficult to secure stable supplies of key parts, such as the permanent magnets used in the robot's arm actuators. Although Tesla is currently working with the Chinese government to obtain export permits, this situation has clearly slowed down production and driven up costs beyond the original expectations. Amid a threatened supply chain and ongoing US-China trade tensions with no signs of easing, Elon Musk's decision to focus sales of Optimus in the US becomes more understandable. It's not only a move to minimize risks stemming from China's export policies, but also a way to maintain tight control over production and distribution, especially since Optimus is still in the developmental stage of newer generations, which involve many proprietary components and lack a stable supply chain. Elon Musk has confirmed this.
Almost everything in Optimus is new. There's not like an existing supply chain for the motors, gearboxes, electronics, actuators, really anything almost anything in the Optimus, apart from the AI for Tesla, the Tesla AI computer, which is the same as the one in the car.
Additionally, China's requirement that Tesla ensures Optimus will not be used for military purposes has made expanding into international markets even more sensitive. When international suppliers demand such a high level of transparency and control, it becomes difficult for Tesla to immediately scale up globally. Therefore, starting with the domestic market is not only a safe choice but also a strategic move, allowing Optimus to develop more stably before going global. Even Elon Musk emphasized in a recent meeting that Tesla currently has a higher degree of localization than any other manufacturer and will continue to strengthen this in the future. However, this is not exactly welcome news for customers outside of North America who have been eagerly waiting for Optimus, as the robot may become not only more expensive, but also much harder to purchase. Unlike Tesla's electric cars, which often just sit in parking lots all day, Optimus robots are designed to actually work, handling tasks for you, and potentially even generating income by performing jobs on your behalf. That said, the term humanoid robot brings about a lot of mixed opinions and reactions. While most of us envision a bright future where these machines take on dangerous, exhausting, or just plain boring tasks, the reality is that many people feel anxious, even fearful, about this vision. They're worried that these machines could replace human jobs, or worse, dominate us, turning us into slaves, just like in the sci-fi movies we've all seen. The image of rogue robots trying to wipe out humanity still lingers in the minds of many. Some people even argue that humanoid robots are just clumsy, slow machines that sometimes look ridiculous. They compare them to wobbly walkers, saying things like, "It's like watching Biden walk," or "like a drunk person stumbling home." And honestly, there's some truth to that. Most humanoid robots today are still struggling to prove they're actually useful in everyday life. Many of them even make people feel secondhand embarrassment due to their lack of refinement, which in turn fuels doubt about their real capabilities. That said, we can't deny that this technology is advancing rapidly every single day. To be fair, we're not here to claim that Tesla currently has the best or most advanced robot, but what we firmly believe is that Tesla's Optimus has the greatest potential to truly make a difference in people's lives. It stands apart from most other humanoid robots out there because Tesla has put immense effort into making it as human-like, in function, and form as possible. Alongside its design, recent advances in AI have given robots truly extraordinary capabilities in just a few years. Put simply, AI is making robots smarter. And humanoid robots are how AI steps into the real world. Take ChatGPT, for example. It can give you an amazing recipe, but it can't go into the kitchen and cook it for you. You still have to do everything yourself. But imagine if that recipe was inside the brain of a humanoid robot like Optimus. What then? At that point, everything changes. Optimus could step into the kitchen and cook full meals, from breakfast to dinner. Elon Musk has stated that what makes the Tesla bot superior to other humanoid robots is its brain. Tesla didn't just stick a standard processor into the robot, it gave it a true AI brain capable of processing real-world information. Don't get it wrong, it's not a biological brain like a human's. When Elon says Tesla bot has a real brain, he's referring to an extremely sharp processing system, one that might even outperform humans in understanding and reacting to the world around it. Sounds crazy. Think of it like this: you don't have to say a word. A simple gesture or facial expression is enough. Point to the floor, and it knows you want it to clean. Rub your belly, and it understands you're hungry. Guests arrive, it automatically prepares drinks. That's Musk's vision, a brain smart enough to read the situation, understand the environment, and act accordingly. This isn't just automation, it's awareness. In some ways, Optimus's brain functions similarly to a human's, because Tesla engineers have explained that it also needs to learn and download data to get smarter. It's like a person learning, gathering knowledge and experience over time to become more intelligent. Of course, Optimus doesn't need decades of school like humans do. Our brains forget things and need repetition, but Optimus remembers from the very first time it receives information. Optimus's exceptional capabilities aren't science fiction. They're built on a powerful AI foundation that Tesla has spent years developing, including machine learning and deep learning. Thanks to this, the Tesla bot can self-adjust and optimize its behavior based on real-life situations, much like how humans learn and adapt every day. This gives Optimus a huge advantage. Users don't have to train the robot from scratch after bringing it home. It's already been pre-trained on countless real-world scenarios and is nearly ready to serve right out of the box. Many people have wondered, I don't want to spend a whole month teaching a robot how to cook, clean, or open doors. With Optimus, that's no longer a concern. Of course, the big question always comes up. If robots become too smart, will humans lose their jobs? But just like how smartphones were once feared to make us overly dependent, when in reality, they created new industries, new roles, and improved quality of life. This is not a threat, it's a transformation in progress. And if you're worried that Optimus might end up like those rebellious robots from movies like I, Robot or Terminator, Elon Musk has made it clear. That is not the goal. Optimus is designed to be a friendly companion, helping with everyday household tasks, from cleaning and cooking to assisting with elderly care. Some people who saw the early videos commented that Optimus walked a bit awkwardly and seemed clumsy. But that's not a flaw, it's a design choice. With a low center of gravity and advanced sensors, Optimus is optimized to maintain balance in tight spaces and on uneven surfaces, areas where other robots would easily lose control. In fact, just earlier this month, Elon Musk released an update that made Optimus walk much more steadily, no longer stumbling like it used to. Internet users used to mock it, calling it the Biden walking robot or drunk robot, but now Optimus has proven the opposite. And here's the key point. When the robot's walk becomes smoother, it means the artificial intelligence inside is evolving as well. It might sound strange, but it's absolutely true. Every step Optimus takes is the result of artificial neural networks processing a massive amount of sensor data in real time. It evaluates the terrain and adjusts its movements, not based on fixed programming, but on adaptive awareness. If the floor is flat, it walks with purpose. If there's a slope, stairs, or obstacle, it automatically adjusts its gait, even bending its legs like a human, to maintain balance. This is a major breakthrough, far beyond traditional robot systems that are constrained by fixed programming. Optimus doesn't just follow commands, it actually understands and adapts. And that's what makes it different. Take cooking as a simple example. You need to review the recipe multiple times, remember the steps, and know how to prepare ingredients. But Optimus organizes and stores data from the very first time. The next time it cooks, it doesn't waste time remembering anything. That's what makes TeslaBot valuable. Elon Musk is confident that Optimus can learn new tasks just by watching videos. Tesla Optimus has significant potential to be sold not only in the US, but also in many markets around the world, and this is entirely feasible when considering the global trends in automation and globalization. One of the major challenges Tesla will face when expanding Optimus production beyond the US is tariffs on raw materials, particularly the permanent magnets imported from China. However, Tesla can certainly find solutions to address this issue. For example, the company could expand its factories in China, like Giga Shanghai, to produce Optimus for the domestic market and neighboring regions such as Southeast Asia. Building a factory in China would help Tesla take advantage of the more affordable supply of components and mitigate the impact of tariff policies on materials imported from China into the US. Moreover, China is a huge market for automation technology, with many industries growing rapidly and a high demand for robots to replace manual labor. This factory would not only serve the domestic demand, but could also export Optimus to other countries in the region. In addition to China, Europe also represents a significant potential market for Tesla. Countries like Germany, France, and the Netherlands are strongly promoting the adoption of automation technologies in their manufacturing industries. Furthermore, Europe has more flexible tariff policies compared to the US, which can help reduce production costs. Tesla could build a factory in Europe, where these policies would assist the company in lowering costs and expanding production more easily. Much like autonomous driving technology, if Tesla Optimus proves effective and reliable in assisting workers and optimizing production processes, it could operate efficiently in any market, regardless of country or region. Therefore, Optimus is not just a product exclusive to the US, but could meet global demand, expand markets, and drive the development of the automation industry worldwide. In addition to announcing that Optimus will primarily be prioritized for the domestic market, what do you think of Elon Musk's statement that, in the future, most people will not buy cars? It might seem contradictory, right? Tesla is the world's leading electric car company, but the CEO of the company claims that the demand for car purchases will drop significantly in the near future. Why would Elon Musk said that? Elon Musk has stated that in the future, personal car ownership will become obsolete, and most people will transition to using Tesla's robo-taxi service. According to Tesla, the new vehicles launched this year will simply be more affordable versions of existing models. Instead, the company is focusing on deploying the Cybercab service this year. Musk emphasized that Tesla plans to deploy millions of self-driving Cybercabs, and by mid-2026, millions of such vehicles will be on the road. This will allow users to summon a ride through an app, much like Uber, but with fully autonomous vehicles. In the United States, the average car is used for less than 6% of the week, and the rest of the time, it sits idle in parking lots. Therefore, rather than remaining stationary, it would be much more beneficial for these cars to participate in the robo-taxi service, where they can generate income for the owner and create revenue. Elon Musk has mentioned that the cost of a Cybercab will only be $30,000, and Tesla can produce one of these vehicles in just 5 seconds on the company's historic production line. The line operates so quickly that humans can't approach it, with everything being automated in a way that's almost unbelievable, earning it a comparison to a high-power electronic production line. Musk also highlighted that the operating cost would be only 20 cents for every 1.6 kilometers traveled, a highly ambitious figure. If accurate, companies operating self-driving taxi services would have very low operational costs when using Tesla vehicles. Experts also predict that by 2030, the cost of using a self-driving car on a subscription basis will be cheaper than owning a personal car, thanks to the convergence of cheaper battery prices, solar energy, electric vehicles, and autonomous driving technology. According to Musk, Cybercab will revolutionize the entire industry, as users will only need to summon a ride from their phone without having to worry about maintenance, insurance, or depreciation when reselling the vehicle. Furthermore, the car business model will transform, as traditional car manufacturers will be forced to shift to providing mobility services rather than selling cars, thus competing with autonomous ride-hailing platforms. Especially with the widespread adoption of robotaxis, the demand for used cars could decline significantly, creating a major shock in the market. Yes, the plan to launch the first robotaxi service is still scheduled for June this year in Austin, but the fleet will only consist of about 10 to 20 cars, as it will still be in the experimental phase on a small scale. This will allow Tesla to collect data on the cybercabs quickly and expand rapidly once the software reaches its peak level of refinement and self-driving permits are fully secured. Elon Musk believes that the development of on-demand self-driving electric cars will render personal car ownership obsolete, much like the transition from landline phones with rotary dials to smartphones. Elon Musk has stated that in the long run, with the development of Tesla Optimus and autonomous driving technology, Tesla could become the most valuable company in the world. This is not just a bold claim, but a well-founded observation when considering the potential both of these technologies offer. Optimus, with its ability to automate manufacturing processes and assist with tasks, could revolutionize the way industries operate, from production to healthcare. Tesla's autonomous driving technology, if widely implemented, would also create a revolution in the transportation industry, reducing accidents and optimizing travel efficiency. With the combination of these two advanced technologies, Tesla is not only mastering the car market, but also expanding into other areas like industrial automation and assistive robotics. This could elevate Tesla to new heights, making the company one of the leading tech giants in the world, as Elon Musk has predicted. What do you think about Optimus and Cybercab? Are these two products the ones that will reshape Tesla? In an era where the pace of technological innovation is measured in seconds, Tesla is once again rewriting the rules of the auto industry with the arrival of the 50,000-ton Giga Press at Giga, Texas. This isn't just a massive machine, it's the mechanical heart of a bold ambition: to produce one cybercab every 5 seconds and put 1 million autonomous vehicles on the road as early as next year. Without the Giga Press, the only machine in the world powerful enough to compress time and precisely cast the entire cybercab frame in a single shot, the dream of mass-market self-driving cars would remain just that, a dream. But now, with every metallic heartbeat under 50,000 tons of pressure, the future isn't far off. It's being forged, one vehicle frame at a time. The 50,000-ton Giga Press is finally being installed at Tesla's Texas factory. But setting up a machine the size of a 4-story building laid on its side doesn't happen in just a week or two. The bigger the machine, the more effort it takes to install. For example, Xpeng's 16,000-ton Giga Press took 120 days to assembling and commissioning. A 50,000-ton beast could easily take twice as long, but when it's done, it will power an EV production line that could shake the entire industry. Elon Musk has emphasized that production speed and efficiency are Tesla's biggest competitive advantages. That's how the company is able to produce a Model Y every 33 seconds at Giga Shanghai. In the quest to cut costs, streamline the supply chain, and accelerate product rollout, Elon identified one key bottleneck: the car's frame. Traditionally, to create the frame of a car, other automakers would require hundreds of parts and thousands of time-consuming, labor-intensive welds that are prone to errors. The labor costs and the need to deploy hundreds of assembly robots are significant. That's why Elon wanted to simplify Tesla's chassis into a single piece. This seemingly impossible idea could only become a reality if there was a machine large enough to cast the entire car body in a single press, and Musk found Idra, a company with a shared vision. Idra, which specializes in manufacturing such presses, realized that components like engine blocks and cylinder heads would no longer be necessary in 10 years when electric motors and batteries dominate. Therefore, to stay relevant and ahead of the industry, they had to take this technology to the next level, leading to the creation of the 6,000-ton, 9,000-ton, and now the 50,000-ton Giga Press. Okay, you might simply think of the Giga Press as a machine that allows Tesla to produce electric car frames faster, and while that's true, it's not the whole story. Thanks to this massive die-casting technology, over 70 individual parts that were once in a Tesla car have been replaced by a single cast piece, reducing the overall weight of the car by 10%, with the Model Y being the best example. The casting time for each part is now just 90 seconds, significantly shortening the production cycle. At the same time, the Giga Press helps Tesla cut production costs by 40% and frees up 30% of factory floor space, which optimizes expansion and operational efficiency. Yeah, you might think that such a big machine would take up a lot of factory space, but if you look closer, deploying the Giga Press means no more hundreds of assembly robots, welding areas, or many other tasks. All those steps have now been condensed into a single machine that can exert 50,000 tons of pressure. It's now just one single, precise, powerful, and flawless casting, down to the millimeter. This precision is what makes Elon Musk confident that Tesla could produce a Cybercab in just 5 seconds, and this machine could even cast 5 Cybercab frames at once.
I think it'll be able to produce a car ultimately in less than 5 seconds. Like, can you imagine a car coming off the line in less than 5 seconds? That's like, whoa. In a single casting machine, we could do like 5 at a time or something, you know? I'm trying to think, like, how do you scale castings? Because you got liquid metal's got to cool, and then you've got to automate, getting all the bits and pieces off the casting so it's usable.
So, how does the 50,000-ton Giga Press work? Clearly, producing a car every 5 seconds is something the automotive industry has never seen before, or rather, it seems like an enormous exaggeration. If this were to happen, it would mean Tesla is breaking its own record, as producing an electric car every 33 seconds is a speed that no automaker has been able to match. With the monolithic casting design of the Cybercab, it could become the only mass-produced car capable of achieving this. An engineer revealed that the number of structural parts in the Cybercab will only be around 80 compared to around 200 in the Model Y, meaning a reduction of more than 60%, which simplifies the assembly and finishing process. The operation mechanism of the 50,000-ton Giga Press is not entirely different from the 6,000-ton or 9,000-ton models. They are still presses, but with different designs and pressures. With the 50,000-ton press, the process still begins with material preparation. Tesla's vehicle frames are primarily made of aluminum, and the Cybercab is no exception. Tesla will melt new aluminum ingots, along with scrap aluminum from previous castings in a furnace heated to approximately 850 degrees Celsius. Afterward, surface impurities are removed before the molten metal is directed through a heat-retaining pipe into another sealed furnace, maintained at temperatures between 750 to 850 degrees Celsius. From what we know, the Giga Press uses a 2-furnace system for processing the aluminum alloy. One furnace is used for melting, powered by natural gas, and operates at around 850 degrees Celsius. The other furnace is used to hold the molten aluminum and is electrically heated to maintain the temperature, as stated. The space in the furnace is filled with nitrogen gas to prevent oxidation and maintain temperature stability. In addition, operators use argon gas, rotary degassing machines, and silicon carbide filters to remove impurities larger than 25 microns. This is the material preparation stage. Next, it's time to prepare the mold. Before each cycle, the Giga Press lubricates the mold surfaces. A robot sprays about 35 milliliters of soybean oil onto the mold, creating a thin and even layer, similar to greasing a cake mold, to make the product easier to separate. Then, a vacuum system is used to remove air, and the molten aluminum is introduced into the mold chamber of the die casting machine. There, the aluminum is pumped into the mold by a high-speed piston. This piston is also lubricated with approximately 8 milliliters of oil before each casting. As we understand, the Giga 6,000-ton press that Tesla uses for the Model Y shoots over 100 kilograms of molten aluminum into a cold chamber mold at a speed of 10 meters per second. The cycle time is about 20 seconds, producing 180 complete castings per hour. That means roughly 4,000 castings can be produced each day across 3 8-hour shifts. However, with the Giga Press 50,000 ton, those numbers could increase significantly. It's important to note that the force used to pump the aluminum into the mold is much lower than the force used to hold the mold in place. The Giga Press 50,000 ton doesn't use 50,000 tons to push the aluminum. It uses that immense force to keep the mold from separating when the aluminum is pumped in. This allows Tesla to cast the entire front and rear sections of the Cybercab frame in a single cycle and potentially multiple molds in the 50,000 ton press, if Elon Musk's claim of being able to cast 5 vehicles at once holds true. The front frame from the driver's feet forward is a single casting. The rear frame from the passenger's feet backward is another. Once the aluminum is injected, it stays in the mold until it solidifies. The casting is then ejected at around 400 degrees Celsius. After that, the rough casting is placed into a cooling tank to rapidly reduce its temperature from 400 degrees Celsius down to about 50 degrees Celsius. This quick cooling process helps eliminate some defects and enhances the material's properties. Finally, the mold opens and is cooled down to around 185 degrees Celsius before a robot thoroughly cleans it, ready for the next cycle to begin in about 1 to 2 minutes. Excess metal is trimmed off and recycled for the next melting cycle. The final product is then X-rayed to check its quality and durability. One of the biggest challenges in the casting process is keeping the mold from cracking under the immense pressure when the molten aluminum is injected. To tackle this, the machine needs to generate an incredibly strong clamping force to keep the mold tightly secured. According to Elon Musk, Tesla has developed an ultra-fast cooling system, a smart mold release mechanism, and an AI-powered automated quality control system to handle this, an integrated technology that no other automaker has tested at this scale.
So I mean, we got to jam the liquid metal in, cool it down real fast, like real fast.
In reality, the process inside the press involves molten aluminum being injected into the mold at high speed. That liquid metal has to perfectly and evenly fill the mold before cooling and solidifying into a sturdy block. The larger and more complex the mold, the farther the metal has to travel, and the higher the chance of defects. If the injection is too fast, air bubbles can ruin the structure. If it's too slow, the metal will cool before it fully fills the mold, resulting in an incomplete product. And all of this takes place inside a massive machine, the size of a house. Musk believes that with the 50,000-ton Giga Press, producing the Cybercab will be like making toys. Yeah, we're not surprised. Alongside the Cybercab, Tesla will likely apply this technology to its upcoming vehicles. These models will probably be prioritized for production in China to compete with lower-cost cars there, and they'll come to the U.S. once the trade tensions between the U.S. and China settle down. Recently, the company's product development director, Lars Moravy, shared some details about Tesla's design process and the affordable models they plan to release. He said, "With the recent upgrades to the Model 3 and Model Y platforms, we've made some pretty great cars at pretty great prices, and we've added a bunch of features. Our intent is not to make a car that is any worse than any car we've ever produced in the past. The models that come out in the next months will resemble in form and shape the cars that we currently make, and the key is that they will be affordable and that you'll be able to buy one. Finally, we have the answers to questions like, what will the Model 2 look like? And will it have a unique design? Yeah, although they haven't outright admitted that the upcoming car will be a more affordable version of the Model Y, based on what Mr. Moravy shared, it's clear that we're looking at a tiny Model Y. Moravy also pointed out that one of Tesla's biggest limitations when designing this affordable model is the existing production lines. To ensure the car meets the target price of under $30,000, it needs to be built on current production lines rather than its own dedicated line, indicating it may be less similar to the Cybercab. It seems the prototype for this car has already begun production in China. Just last month, a Chinese news outlet revealed that Tesla is making a stripped-down version of the Model Y. Meanwhile, Toyota has officially launched a new high-end electric sedan called the BZ7. This move is seen as a strategic attempt by Toyota to reclaim market share in China, where they've been gradually losing ground to the surge of local brands. With its modern design, advanced technology, and production partnership with GAC, one of China's major automakers, the BZ7 is set to be a new competitor to popular electric sedans like the Tesla Model 3, BYD Seal, and XPeng P7 Plus. The BZ7 boasts impressive dimensions with a length of over 5 meters, making it nearly equivalent to the Tesla Model S. Its sporty coupe design gives it a powerful yet elegant feel. Inside, the BZ7 stands out with a combination of minimalist and premium styling. The large central entertainment screen runs on Huawei's Harmony OS digital instrument cluster is sleek and minimalistic, and the wood trim combined with ambient lighting creates a luxurious atmosphere without being too flashy. The center console retains physical buttons, providing a more intuitive user experience compared to many current electric vehicles. In terms of technology, Toyota's choice of Harmony OS indicates a strong focus on connectivity and user experience, an area Tesla has excelled in. The Tesla Model 3 is well known for its constantly updated entertainment system and software, so Toyota will need to offer an equivalent experience if it wants to stay competitive. However, Toyota faces several significant challenges. While the BZ7's design and technology are appealing, Toyota's brand image in the electric vehicle space, especially in China, remains relatively weak. Chinese consumers today typically think of local brands like BYD, NIO, XPeng, or Zeekr when considering advanced electric vehicles, and Toyota is rarely top of mind. This is a major hurdle that the BZ7 will have to overcome if it hopes to succeed. In terms of performance, Toyota has yet to reveal the specific technical details of the BZ7, but based on previous electric models, many question Toyota's ability to compete with Tesla in areas like energy efficiency, charging speed, and battery technology. The Tesla Model 3, with its proprietary technology and widespread supercharging network, continues to lead in providing an overall superior electric vehicle experience. If Toyota doesn't deliver significant breakthroughs in performance, the BZ7 could struggle to convince consumers, especially those who are tech enthusiasts. Another challenge is the global strategy. While Tesla continues to rapidly expand into markets like the US, Europe, and Southeast Asia, Toyota is still primarily focusing its electric vehicle efforts on the Chinese market. If the BZ7 remains a domestic-only model without an international rollout, its ability to compete with Tesla, a truly global brand, will be limited. For us, one of the most exciting aspects of Giga Press is the collaboration between two companies that are constantly innovating. Elon Musk shared that he drew inspiration from a Hot Wheels Model S toy sitting on his desk at Tesla's Fremont factory. Hot Wheels are made from die-cast metal or molded plastic, which is why they are cheap and mass-produced. Giga Press was inspired by that idea. This also marks the first time the automotive industry has shifted to a production model similar to electronics manufacturing, fast, streamlined, and highly optimized in space. While Tesla has been leading the way in applying Giga Press, the use of large-scale die-casting technology in vehicle production is no longer limited to Tesla. Major automakers like Ford, GM, Toyota, Hyundai, and XPeng are starting to adopt it as well. This shows that Giga Press is becoming a key player in the modern automotive manufacturing revolution. Automakers are beginning to recognize the huge benefits that Giga Press brings: reduced production costs, improved product quality, lower emissions, and increased output. However, achieving even greater capacities will require significant improvements in both machinery technology and manufacturing processes. Larger die-casting machines, such as 50,000-ton, 70,000-ton, or even 100,000-ton presses, will be able to produce larger and more complex automotive parts, further reducing costs and improving manufacturing efficiency. Expanding die-casting capacity will not only provide cost benefits but also open up opportunities to create higher quality, more durable, and environmentally friendly automotive products. An important factor in this process is the ability to recycle aluminum within the Giga Press, which helps reduce the environmental impact. This is one of the key advancements in achieving the sustainability goals that Tesla and other automakers are pursuing. If larger die-casting machines can more effectively utilize recycled materials, it will reduce emissions and protect the environment, while also supporting the global energy transition. Furthermore, scaling up Giga Press will drive suppliers to innovate, leading to new materials and production processes. This will not only impact the automotive industry, but could also positively affect other sectors, such as machinery manufacturing, material production, and heavy industries. Software tools that assist engineers in designing and producing Giga Press castings will continue to improve, helping optimize production processes and enhance work efficiency. In conclusion, the future of Giga Press has the potential to elevate the automotive industry to a new level, not only in terms of production, but also in efficiency and sustainability. With ongoing technological advancements and limitless innovation, Tesla and its partners may develop even larger Giga Press machines, with capacities ranging from 60,000 tons to 100,000 tons, transforming the automotive industry and accelerating the global energy transition.